An electron has a mass, we know that. Calculate the de Broglie wavelength for an electron traveling at this speed. Okay, so we know its mass, that's always the same. And we're told its speed. So it's not quite the speed of EMR, but it's moving pretty fast. So because it's traveling at such fast speeds, it's going to have wave-like properties. So our de Broglie formula is lambda is equal to h over mv. And we got that by going m times v is equal to h over lambda. So as I said, you must use the h that has the joules in it. So we go 6.63 10 to the negative 34 divided by 3.384 times 10 to the negative 10 meters. We got 3.38 times 10 to the negative 10. So not too bad of a calculation, pretty straightforward so far. Next, calculate the wavelength of an electron that has a given kinetic energy. Okay, so all we have is kinetic energy. Now, what you want to think when you're doing these formulas is, can I get speed from the information I'm given? Okay, yes, we can find speed using Ek equals half mv squared. Oh, sorry, I'm not looking for Ek. I have Ek. Because if you can find speed, you can put it into the de Broglie formula and find your wavelength. So when you're kind of given what you have, think, can I find speed from the information I'm given? So V is equal to square root 2Ek over M. So I got a speed of 2.6087 times 10 to the 7 meters per second. And keep in mind, if you're given, say, if you were given the energy in EV, you need to convert it to joules before you put it into Ek equals half mv squared. So then my second calculation I can do is to put it into my de Broglie wavelength formula. So I get a wavelength of 2.789 times 10 to the negative 11. So to sig digs, 2.79 times 10 to the negative 11 meters. Now, so that's all for kind of your main examples, but I just want to give you a heads up with one. So say you were given the voltage, okay? So say you're given something like a potential voltage, a potential difference. So that would be like V. So say you were only given V and you were asked to find wavelength. Okay. What can I find from V? Your Ek, yeah. So when I relate V to Ek, it's that is under what section is that? That's probably electricity. Yeah, under electricity and magnetism, like if it's accelerated across an electron. Oops.
Atomic physics.
Oh, thanks. Yes, yeah. So then I have Ek is equal to V times QE. Okay. So if you can then find Ek, you can find speed and then put it in. So I'm just giving you a heads up if you get to a question like that. Use that. Okay, so do numerical response on the back there, and then I'll give you your workbook for this one.